domain theory. The domain theory. The domain theory. A magnet is made up of a group which is called the magnetic domain. A magnet, this one now, let's say this one is a bar magnet. This bar magnet is having a group of subatomic magnet. So, for example, if we break this magnet like this to have pieces of this magnet, this one now is a bar magnet. This one is a bar magnet. Okay, let's say this one is in and this one is out. This group now, which is formed from that magnet, is called domain. So this one now is domain. And the domain will retain the magnetic axis. For example, this one is north, this one will be south. It will be retaining its magnetic axis. This one will be north and this one is south. This one is north, this one is south. So this one is what we call the domain. In that domain is having a smaller subatomic magnet also. This one is having a smaller subatomic magnet. For example, these are now this domain here. This one is domain. This one is domain. This one is domain. Okay, if we further break this one now, it will be containing a small pieces which is called the dipoles. So this one will have this one to be the dipoles. If we break this one further, if we break the domain further, it is having the dipoles. So this one now is what we call the dipoles. A bar magnet is this one. When we break that bar magnet into small groups, we call it domain. When we further break the domain, it will be having the dipoles. And we have three conditions now. We have a magnetized condition, unmagnetized condition, and saturated condition. For example, if we have this condition here, let's say unmagnetized condition. In unmagnetized condition now, remember in this one we are talking about the magnetic material, and we know the magnetic material is just attracted by the magnet, but it is not a magnet. In unmagnetized condition now, this one is what we have. Inside that one we have the dipoles. Let's say this one is the dipoles here. In unmagnetized condition, the dipoles face in all directions. So then we find the direction of the dipoles is facing in all directions. This one is unmagnetized condition. So this one now it is facing in all directions. The dipoles face in all directions. This one is unmagnetized condition. What do when we magnetize this one? Remember we had we will be having magnetization. So then when we magnetize this one, what will happen to the dipoles? So we have also the magnetized condition. In magnetized condition, the dipoles will face now in one direction. So this one now is magnetized condition. We have also the dipoles here. The dipoles will face in one direction. We find these dipoles now facing in one direction. If the dipoles face in one direction, that means that material is magnetized. If the dipole is facing different direction, we say it is unmagnetized. If we further magnetize this one here, we will have what we call saturated condition. In saturated condition, this one is what we have in saturated condition. So then this one is the dipoles also. We have the dipoles. In saturated condition, all the dipoles now strictly now face in one direction. So this one now, all of them face in the same direction. So then you will find this one now, all of them is aligned to one direction. This one is facing in one direction, but it is not aligned strictly to one direction for this. This one now is a magnetized condition. This one is magnetized, and this one is a saturated condition. That means now, in a saturated condition, there is no further magnetization. All of them now is fully magnetized, and then they are now facing in one direction. So that now is about the domain theory. This one is what we have in the domain theory. We have the domain itself. That's now we say when we break a magnet, it will be having a group of a magnet, which is called the domain. And that one, that domain is having a smaller subatomic magnet, which is called the dipole. So all this one is the dipoles. And then in this one now, the dipoles depend on the condition of that material. If it is magnetized, it is this. If it is saturated, this one. If it is magnetized, that one is what we have in that one. So we are now in the fifth one, which is magnetization of a magnetic material. 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 What is magnetization? Magnetization is the process of making a magnet from a magnetic material. Magnetization of a magnetic material. What is magnetization? Magnetization is the process of making a magnet from a magnetic material. Magnetization is the process of making a magnet. Is the process of making a magnet from a magnetic material. From a magnetic material. From a magnetic material. So magnetization is the process of making a magnet from a magnetic material. We have 4 methods of magnetization. We have 4 methods of magnetization. We have 4 methods of magnetization. So methods of magnetization. Methods of magnetization. We have 4 methods. The first method is induction method. Number 2, stroking method. Stroking method. Number 3, hammering method. And the last one, electrical method. So those are the methods which is methods of magnetization we have. Okay, I have a magnet here. I have a magnet, and I will show you this magnet, which is the bar magnet. We will start from the first one, which is the induction method. Induction method. In induction method, a magnetic material is induced, the magnetic field. The magnet induced the magnetic properties to the magnetic material. For example, if I have a magnet, a bar magnet, this one is a bar magnet, let's say this one is not and this one is not. If I take a pin, for example, if I take a pin like this, this one is a pin. If I take a pin and then you place it here, you will find that pin is attracted by that magnet. The pin is attracted by the magnet. When you then get a pin downwards here, you will find this pin will attract this one. What does that one mean? That means this pin, the first pin, have been induced the magnetic properties, and then it acts now as a magnet. For example, I have this one to be the magnet. I have a pin here. This one is a pin. So which means the magnet attracts the pin. When I take the second pin and then I place it here, you will find the first pin attracts the second pin. What is the meaning of that? That means the first pin now acts as a magnet. It has been magnetized by the permanent magnet. And this method now is called induction method. This method is called induction method. What is the polarities now of this magnetized material? If this one is a North Pole, even this pin now, because it is now a magnet, it will acquire polarities. And then this point will acquire an opposite of this, it will be South Pole. The end of that one will be a North Pole. This one now is magnetized. So this one now will be a South Pole, and this one will be a North Pole. If we further add the other pin upper, this point here, that pin also will be attracted by this, which means also this one is magnetized. So this one will be South Pole, and this one will be North Pole. This one is what we call induction method. The magnet itself induced the magnetic properties to that magnetic material, and then being magnetized. And that now is what we have. Okay, let's say also we have a magnet. Let's say we have a magnet. And we place a pin here, and we place the other pin here. Let's say we have two pins. This one is south, this one is north. You will find these points will repel each other. The 2 points will repel each other. So